drawing quadratic functions. Essentially, I think it's called drawing curves as a heading. Yeah, graphing curves. Right, so drawing or graphing, the curves are going to be quadratic functions. So, fair amount of notes to start today off with. You got this guy here, ax squared plus bx plus c. Do you recognize that guy? Don't do that face, Tara. Do you recognize that guy? Yes, you do, right? It's a standard form for a quadratic. It's a standard form. So what we're going to look at is different versions of this quadratic and how you can sketch them. So I'm going to start off with the simplest kind. And that is quadratics that look like this. And here are two examples. I'll call them number 1 and 2. So all you get is an x squared term, right? It could be 2x squared, minus 4x squared, 5x squared, but just a multiple, right? No x's, no plus 3's, right? No x's, no plus 3's. Now, if you wanted to sketch either of these two guys, and you weren't doing it in WebAssign, so if you just wanted to do a very basic sketch of it, let's show you what it looks like. All quadratics in the universe have two shapes. They either look like a happy face or they look like a sad face. That's the two shapes that every quadratic, including this one, has, right? And these have special names, in case you see them written down anywhere. This is called concave up. And this shape here is called concave down. So if you see me saying happy face, I'm talking about concave up. If I say sad face, it's concave down. Now, for a guy like 3x squared, as long as that number next to the x squared is positive, right? So 2x squared and 5x squared count, you get a happy face. That's what it looks like. A very rough, not putting any details in it. So 3x squared would look very roughly like that guy. Now you might say, well, how do I know that? Well, if you wanted to do it in a little bit more detail, couldn't you do a table of values, x equals -1, 0, 1, 2, 3, you know, plot 5 or 6 different dots and then join them up, right? But can you just trust me that that's what it looks like, right? Happy face. Now, when you have the alternate situation, like a -2x squared, a -x squared, a -42x squared, then it's going to be a sad face and a concave down. So this guy looks like that. And there's one thing, which I haven't mentioned yet, but you can look, you can see it. Do you notice that the bottom, if you think of that as a valley now, or the top of that hill, doesn't it pass through the origin? And that's because functions that look like this, right? Any of these two functions here, one of the points that they're guaranteed to pass through is the origin. And you can check that. If x is 0, won't y be 3x squared, right? So y will be 3 times nothing squared, y will be nothing. So if x is nothing, y is nothing. If x is nothing, y is nothing. So if you get a question, as you will, on WebAssign, and it asks you to sketch these kind of guys, we need a little bit more detail. So I'm going to go back to the first one. And you might say, well, what details do I need? You need 2 points, right? So you need the coordinates of 2 points to work with WebAssign. One of them is this guy here. So now I need one more point that's on this curve. And if f of x kind of distracts you, well, y equals 3x squared. Does that look a little bit cleaner in your brain? Do you want to see it that way? Okay, so we'll call it y equals 3x squared. What I need one more coordinate. Any point at all, but let's not make it ridiculously ugly numbers to calculate. Tell me how I could find one more point on this quadratic. How could I find another coordinate on this quadratic? It's a little clue.
You could replace x with a value to calculate y.
Okay, and pick a nice number.
1.
Yes, don't pick 42. It would be a bad idea, right? Pick 1. Now, if you pick 1, won't the y value be 3 times whatever the x value is squared? Now, when you pick 1, 1 squared is still 1, and 3 times 1 is 3. So there are your 2 points. And so in WebAssign, if you want to sketch a curve like 3x squared, or later on we'll do negative 2x squared, what you need are just 2 points. WebAssign will figure out the rest for you. The origin, because when x is 0, y is 0, I think that's a really good point, isn't it? It's a nice, easy one to get, and it's always going to be there when the questions look like this. And then pick x as 1 or 2, I guess, if you felt like it, but I like 1. So let's show you how that works in WebAssign. A couple of people just turning up. I didn't know we're going to have a musical interlude, but never mind. So let's, whoops, I think. There we go. I got the usual carry on. I'm going to put a mute on that just so we don't get that again. Right, so here goes. Right now, with a bit of luck, you should be looking at our WebAssign page. Is that what you can see, guys?
I can see that.
Okay, good. So I'm just going to make it a little bit bigger. And there's that 3x squared that I was talking about. So if you want to do a quadratic, you hit this funny, yeah, it looks a bit like a quadratic, doesn't it? It looks like a little happy face. Now you click on this one, right, the first one, and you put a 0, 0 and a 1, 3, and you're done. Is that easy? 0, 0, 1, 3, and it fills in the rest for you. That's pretty cool that WebAssign will do everything else. Because once you've told it those 2 points, it kind of knows what curve looks like and it fills in the gap. Any questions about that guy?
Okay, wait, what did you do? Because it didn't want to plot it just now. So I want to make sure I know how.
Okay, let's delete that one. The little curvy one, right? The happy face
Okay,
shape.
got it.
Pick that one. And the 2 points that we had, although you can't see them anymore, are 0, 0. And the other one is 1, 3. And if you think you might have missed a point, can't you go over here and just check the coordinates to make sure that they are 0, 0, and 1, 3, just in case it's, I don't know, 1, 2.9 or something, right? In case you're almost right, but not quite. And that's pretty much all you need to do to do a sketch of a quadratic in WebAssign. You need to know 2 specific points, right? When it's a 3x squared one, you got that. Now I'm going to come back out for a minute and we'll look at the second situation that I set up for you.
Professor, I have a question.
Yes. Go for it.
Which chapter is this lesson? Is it 15.2 or?
This one is 15.3 graphing curves.
Gotcha, okay.
So I should put it over here, 15.3. Now, the second one is negative 2x squared, right? Now, we know it's going to have that shape because any quadratic that has a negative number next to the x squared is always going to be concave down, right? It's always going to be a sad, a frown, a sad face. Now, I'll set up my little table. And if x is 0, won't y just be negative 2 times nothing squared, which is 0? So there's my favorite point. And why break a good habit when it's working? Maybe we could choose 1 again. Right now, negative 2 times 1 squared is negative 2 times 1, because 1 squared is still 1. And that gets me the number negative 2. So here are the only 2 points I need to sketch this quadratic in WebAssign, right? I just need to know the origin and one more point. So I'm now going to return to WebAssign eventually. Okay. It's fighting me as it always wants to. Finally got through to the window I needed. And here we are. You're looking at WebAssign again, right? I don't know, maybe get a little bit bigger on this. Can I do it without making it? Okay, that's probably as big as it's going to get. Right, I'm going to use this blank one again. So to draw negative 2x squared, we click over here, right? Now, I know this seems, that's what I'm looking for. It seems wrong, but you still have to click the happy face. And you click 0, 0, and 1, negative 2. Right. So happy face, 0, 0, 1, negative 2. You see it, it draws the right curve. It draws the sad version of it. So I don't think that's a big deal, right? You always use the happy face symbol, even though half the time you're going to be drawing sad face quadratics, right? They don't have a happy face quadratic symbol and a sad face one, right? You just use one symbol for both situations. Are we good with that? Any questions about sketching quadratics that just have x squareds in them? Now, let me show you a different version of the homework question. Here is the guy, 1/5 x squared. One of these pictures, and only one of these pictures, would look like this guy. So is it picture 1, top right, bottom left, bottom right? Which one of those 4 pictures is 1/5 x squared?
Wouldn't it still be the top right because it's weird?
You're right, it would be. And let's talk about the clues here. Would you agree this one's pointing the wrong way? And
Yeah.
would you agree that that one's pointing definitely the wrong way? And so what do we have? We have a happy face and a sad face, right? That's our choices. And would you agree that it's a 1/5? That's a positive number, so it's a happy face. And that's why I picked that one. Would that be kind of how your brain was working?
Yeah.
Right. Or you might just say, I know that's a happy face, so you just pick the happy face one and you don't need to kill off the others. Right. Now, okay, that's as far as we have got, right? So I'm now going to move on to more quadratics, but a little bit different looking. So that's how you do quadratics that have just x squareds, right? And there's two examples of. Now we're going to do, I think I'll stick to the y's. Let's do 2x squared plus 1 and 3x squared minus 1. And we'll look at what did they look like. Well, let's create a table for the first one. So that's going to be for the 2x squared plus 1. Now, if you make x0 and x1, for these questions, that's going to be a really good choice. Later on, we have to be a little bit more adaptive, but right now it's a good choice. So for this top one, I guess, number 1, is this guy going to be a happy face or a sad face?
Going to be positive. So happy.
Okay, happy face, concave up. In fact, so's this one. But you might say, well, what about this -1? It doesn't matter what that number is. It could be +1 or -1,000,000. The only thing that decides the shape of a quadratic is the number next to the x squared. Whatever else comes after that, and there will be more and more complicated things coming after that, whatever comes after that does not affect the basic shape, right? A 2x squared or a 4x squared or a 3x squared are all happy faces, right? They're all concave up. A -2x squared or a -4x squared, they're going to be the sad faces, right? They're going to be the concave downs. So we already know, just looking at a quadratic in a very crude kind of way, that it's going to be a happy face, right? In both cases, right? Now, if you put 0 and you plug it into here, you get 1. If you put 1 and you plug into here, you get 3. So that's going to be 0, 0. Oh, sorry, 0, 1. It's here. And then 1, 3, which is here. And this point at the bottom, does anybody know what name you give to this point at the bottom? Starts with the letter V.
Isn't that the vertex?
Yes. So what you're going to do in every quadratic, including the ones that we've done and are about to do, is that one of these 2 points has to be the vertex so that WebAssign knows the orientation of the happy face or the sad face, right? So WebAssign says, you better tell me a vertex or I'm in trouble, right? And so we know that it's going to be a vertex. Well, at x equals 0, we got 1, so that's definitely a vertex. And at 1, 3, for these shapes, that works really fine. Later on, we'll tell you a little bit different.
Professor,
And
I have a question.
yes.
So that also looks like it's also the y-intercept. Is the vertex always the y-intercept?
No, because it is for these questions.
Okay.
In general, it's not, but you're correct. That is also the y-intercept. Oh, by the way, in these questions here, that is a vertex. It's also a y-intercept and it's also an x-intercept. So it's a bit like a lot of everything, right? It's got different names depending on how you want to look at it. Now let's look at the second fella. So if you have only x squareds or only x squareds plus or minus numbers, the x equals 0 guy is going to give you the vertex. And if I plug in 1 here, what do I get? 2. So I'm going to have the vertex at 0, -1, and then at 1, 2, the other point. So this is what 3x squared take away 1 looks like. And this is what 2x squared plus 1 looks like. And these tables of values are going to be how we would get WebAssign to sketch or to draw these guys, right? Sometimes you'll find that WebAssign really just gives you a choice of 4 pictures. And if you know which, what particular question you're looking at, you should be able to just choose a picture. So 2x squared plus 1, 3x squared minus 1. Cool. Now, if I wanted to do it in WebAssign, I would plot these 2 points or these 2 points if it gave me the option of graphing it. Okay, happy face or sad face for these 2 situations, these 2 functions. Happy or sad? Positive number next to the x squared, happy.
Those are sad.
Those are sad. The correct term is concave down, but I think sad faces are easier to remember, aren't they? As a word, right? So they're called concave down. That's their jargon. Now, I would like to sketch these guys, right? Because if I can sketch them on paper, can't I then go and look at the 4 pictures and pick the one that looks like mine, right? Because there's going to be 4 of them, but only one's going to look like mine. Now, if you plug in x is 0, you'll get the coordinates of the vertex, which in this case is 1. And if you plug in 1, you get -2. And so that's going to be 0, 1, which is here, and 1, -2, which is here. And I know that's the vertex, so there we go.
Wait, Professor, when you wrote that originally, you said -3x squared plus 2?
Uh-huh. Oh, but I never did it here. Oh, shooting space. You're right. Can I fix it? Can't really. Draw it again with the real data. So I think I scanned in there and put a 1 for some reason. So 0, 2 takes me to here. And 1, -2 takes me to here. And we know it's a sad face, so it probably looks something like that. So that's what -3x squared plus 2 looks like. So I'll put a little arrow because my next table is going to go right underneath it. I'm going to pick 0 and 1. -2 lots in nothing squared, still nothing. Take away 1 gets you -1. -2 lots of 1 squared is -2. Take away 1 more, you get -3. This guy here, gonna have to cheat a little bit. Can we pretend that's 0, 1, and that this is 1, -3? So my guy would look something like that. No, he doesn't. -2x squared, -1, right? This table here, just rewriting it cleanly so I don't scan all over the place, right? That guy. 0, -1, 1, -3, right? Now I'll draw a good version of it. 0, -1 is here. And 1, -3 is here. There you go. Are we cool with negative x squareds of some kind plus or minus a number and what they look like? Positive x squareds and plus or minus a number, what they look like. So we have those two guys, positive x squared with a number, positive x squared, take away a number, negative x squared, add a number, negative so many x squares, take away a number. Wouldn't you like to see a shortcut? A quick way of doing that. So let me show you a shortcut. So it's in the notes, shortcut for graphing. These four guys. That's essentially every permutation you could get with plus and negative x squareds and add and subtract after it. And here is the shortcut. This guy is a happy face. And that guy is -7. So if you want to sketch number 1, what you do is you start off with a sad face. Oh, sorry, this one. Start again. This first one, you start off with a happy face, and then you go down 7. So you imagine this is -7. Now, 3x squared plus 2, start off with a happy face, move up to. So the key to the shortcut is that term there. Like someone mentioned earlier on, isn't that the y-intercept? Yes, it is in this case. So if I wanted to do a very quick sketch without any detail of this guy, what shape, happy or sad face, is -3x squared?
That's concave down.
Correct. And where's the vertex going to go?
-1 on the y-axis.
There's the sketch. See how quick it was? Sad face, down 1. Would you agree this guy is a concave down, a sad face? Where does the vertex go? Where's the y-intercept, which is actually the same thing in this case?
3, +3 on the y-axis, so up 3.
So a sad face, there. See how quick that was? If you're only interested in a very rough sketch of it, you could even do away with the table of values. You could simply just use the property that you know if it's a concave up, happy face, concave down, sad face. And the second property is that this constant term all of them tell you where it crosses the y-axis. It also tells you where the vertex is because of the same thing when it's written this form. Are we good? I'm going to show you what that looks like in WebAssign as homework questions, because this section, at least the beginning of this one, is pretty quick because you don't actually get to do too much, in my opinion. Right, here we go. Now, I'm probably going to have to shrink this thing down if we want to see all four choices. I'm not sure if I can. There we go. So, although you might not be able to read it, one of these four guys is x squared minus 5. X squared minus 5. Where is he?
Bottom left.
I'm pretty confident bottom left. Can I see some nods? Not just because you want to nod, but you agree. Bottom left. Let's see if it's got all the features. It's x squared. Happy face. -5 means it crosses the y-axis at -5, and that's the same place that the vertex is. Doesn't this one match all of those things? That's the right one. Okay, which one of these four is x squared plus 3 then? X squared plus 3. Which one of those four would be it? You may have to hit spacebar if you're answering.
Isn't it also the bottom left?
Yes, because WebAssign has no imagination whatsoever and didn't even mix them. Or it might be sheer coincidence, I guess. Okay, I'll just hide the question. Which one of these is 7 take away x squared? Which I haven't written it that way, but one of these is 7 take away x squared. If I called it negative x squared plus 7, would that help?
It's also the bottom left.
Oh, come, yes it is. God, that's annoying. So, apart from the fact that if you don't know the answer, you just pick the bottom left, because that seems to be the only place where the right answers live right now. If you get a question and it asks you which one of them looks like that, you got to remember that you can also write it like that. It's the same thing, right?
So in the middle of these questions, or right before it goes into those style questions, it has a weird one that has a fraction. And
What question number was it?
it's number 4.
I missed it.
Yeah, it has
Okay.
it does it as a fraction. It's
Oh,
spelled-
that doesn't matter. I'll show you. 1/5 x squared, right? Now that just has x squares, agreed? When you are just in x squared, aren't you a happy face, whether it's 5x squared or 1/5 x squared? And since you are just x squared, isn't your vertex your origin? So that's what it would look like. 2x squared, 1/2 x squared. Still x squareds, still happy face, still at the origin. What would this one, I don't think they did it, but what would this one look like then? (1/5 x squared plus 1. What would that sketch look like?
Well, your y-intercept is still in the same spot, right? And it's a positive, your x is positive, so it's going to be a concave up at the +1 as your vortex or your middle point.
And you have now sussed out how to do those, right?
No, I did the first two totally long-handed.
Okay, but now
You
you
were
can
slow
do
today.
but You can see that we have a shortcut way to do it as well, don't we now? And it's
But when
all
does that not work?
well, it works for the two situations that we've talked about. And just to remind you who those two situations are, it's x squareds on their own, like 3x squared and 5x squared and minus 2x squared. And when you do that, won't the vertex be at the origin? And it'll work for things like, you know, minus x squared plus 7 and a fifth x squared plus 1 or minus 2, in which case it's, you know, the y-intercept or the vertex, because it's going to be the same place, is wherever this number is. So in this case, it would be at 1. So it works for everything that we've seen so far. Doesn't work for every possible one, but it works for 2 out of the 3, which is not a bad average. Right, x squared on its own, it works. X squared plus a number or x squared take away a number, it works for those situations. So I'm just saying if we're covered yet. No, we haven't finished the x squared with the number ones yet, so let's have a look at that one. Okay, this one is negative 3x squared plus 4. And at least it's not the bottom left. Negative 3x squared plus 4. Which one of those would be the graph of that guy?
It's gonna be the bottom left. Wait, is that right or left? I don't know. It's
That's
the bottom
right.
big one.
That one. The bottom right. That's what you're trying to tell me, right?
You sideways to me, so that was a really awkward trying to figure that out.
I always remember I write with my right. Don't know if that helps any.
I'm used to doing medical, so everything I think everything opposite. It took me a long time to get to that place. So it's my left.
Okay. So here is a 2x squared minus 1 guy. Again, this should be pretty much the same as the other choices. Happy face or sad face for this one?
Happy.
And where's it going to cross the y-axis? And that's its
Negative
vertex.
1.
So doesn't that combination make it this fourth one here? Okay, right? We're almost finished these questions. So there's only one last bit to do, right? But we're still on these ones. So let's use them up while they're here then. Negative 2x squared plus 3.
Sad face plus 3.
And I'm hearing sad face plus 3. Do we all agree then it's back to bottom left because they like that place? Right, okay, we're on to the last stage then. What we've just shown you is the shortcut technique, and you can also do a table of values if you find that more useful. You kind of need the table of values if you're going to do it in WebAssign, because WebAssign needs 2 points, right? It needs to know where the vertex is and one more. So that's why I've basically had to show you the table, right? But as long as it's one of those questions where here is 4 pictures, pick the right one, you can do the shortcut method pretty quickly on those, right? So what we're now looking at is this fella, the last situation. How to sketch quadratics that have all 3 pieces. They have an x squared, and it might be 2x squared or 5x squared the next time, but they'll have x squareds. Could be negative x squareds even. It's going to probably have some x's and probably have some numbers. It's going to have like all the bits, right? Now, the key to doing these type of sketches, right, if you want to do them quickly, and that's what we want, is to find 2 things. Find a shape. In other words, is it going to be a happy or a sad face? And then find the coordinates of the vertex. Right, finding the shape should be pretty easy because it's the same rule for everyone we've done so far. Happy face or sad face for this guy?
Isn't it going to be a sad face since there is a negative?
Where does the negative need to be to make it a sad face? Because this negative is next to the x's. but where should it be if it's going to be a sad face?
It should be with A, so
Yeah.
in front of the x squared.
Right, so it needs to be the number in front of the x squared. Since there's technically no number there, doesn't it mean it's +1, right?
Yeah.
So that makes this guy, right, this one here, I guess I have to put color scheme in. This makes this a happy face. Now, for the other two questions, the vertex was pretty easy, wasn't it? It was either at the origin or it was, you know, if it was +3 at the end, it would be there. That number there is not the vertex, right? That's not the vertex. This is how you find the vertex. You use a formula. The x coordinate of the vertex, it's -b over 2a. Now, this guy here, and this guy here, the first one is A, the second guy is B, and the third guy is C. Remember the naming of A, B's, and C's. Right. So, the x coordinate of the vertex is the negative of -2 divided by 2 times 1. 2 negatives make that a plus. 2 times 1 makes that a 2. The x coordinate of the vertex is 1. Then you find the y coordinate of the vertex. Okay, if I know the x coordinate of the vertex is 1, how do I find the y coordinate of the vertex?
Wouldn't you just plug it back into your equation?
You do exactly what you just said, yes. So here's the equation I'm going to use, and I'm plugging it in, so it's 1 squared, take away 2 lots of 1 plus 1. I wish this answer hadn't appeared, but it's the right answer, so I'm going to live with it. It's 0. So that makes the vertex 1, 0. Now, once you've got those two pieces of information, you can do a pretty quick sketch. You plot the vertex, which is at 1, 0. Do you notice how the vertex is now shifted to the right? It's at 1, 0. And it's a 1, 0 happy face. Shoot. Are we good on that? 1, 0 happy face. Okay, let's do another one. So for every one of these last guys, we're going to figure out the shape, which is pretty easy. And then we're going to calculate the coordinates of the vertex, and that's where the work's going to be. So how about y equals 4x squared plus 12x minus 3. I'm picking really ugly numbers because I don't want nice answers like 0 all the time. What shape will this have? Happy or sad? The only number that matters is this, the coefficient of x squared, right? The number next to the x squared, that's 4 here. Happy or sad?
Concave up, happy face.
Happy face, concave up. Now, the x coordinate of the vertex is -b over 2a. So in this case, a is 4, b is positive 12, and c is -3. But since this formula doesn't even use c, I could probably ignore that. So it's going to be negative of 12 over 2 times, okay, 4. And that's going to get me -12 over 8. And that's what, -3/2, or I guess -1.5. And what's the y coordinate going to be then? Well, it's going to be whatever this gets you when x is that number. So it's 4 lots of negative 1.5 squared plus 12 lots of negative 1.5, take away 3. So that's positive 2.25. 4 times 2.25 gets you 9. Take away 18, take away 3. I believe the answer is negative 12. So the vertex would be negative 1.5, negative 12, and it would be a happy face. So can you imagine negative 1.5 being here? And can we pretend that negative 12 is here? And then all you have to finish with is a happy face. So if you know the vertex and the shape, can't you draw a very primitive sketch of the quadratic? Vertex and shape, or shape and vertex, you want to say it that way around. Are we good? Right, let's don't have too many to pick from. So here's, I don't want that one, it's boring. Oh, this one's interesting. Right, this is question 13. And it's y equals x squared, take away 4x, add 1. And we're going to be doing a sketch of it. And once we've got a sketch, we'll go and look at the homework and we'll pick the one that looks like it. Just getting my thing set up. Okay, what's the shape? Concave up, concave down for this guy?
Concave up.
Agree? Do I care what that is? Nope, not for the shape. Do I care what that is? Nope. Do I care if they're even there? Nope. Do I care if one of them's there? Nope. Do I care if that one's there? Still nope. The only thing is the number next to the x squared. That's all that matters for the shape. So you just kind of laser focus on what's going on there. Well, it's an x squared, so it's a 1 plus 1. Happy face. Then A is 1 and B is negative 4. And I'm not bothering to write the value of C down anymore because I don't use it. The x coordinate is the negative of that guy over 2 times 1. Positive 4 over 2. Yay, I get an x coordinate of 2. The y coordinate of the vertex, plug in 2, you get 2 squared. Take away 4 lots of 2, add 1, and I believe 4, you get negative 3. So the coordinates of the vertex are 2, negative 3. And so plot a vertex at 2, negative 3, which is about here, and happy face it. So that's my guy. Let's look at what the choices are. Darn it, this thing's a pain in the butt. I did not swear. Did you notice that? I did not swear. I was sorely tempted. I got a lot of chats. What's going on? Okay. That wasn't too important. Right, here's the guy. Which one of those 4 guys looks like the picture I just drew? You'll have to hit the space bar if you're talking, Tara.
I'm giving my fellow students an opportunity to talk.
Okay, good idea. Come on, class participation here. Let's join in. Somebody else chuck in an answer. Which one of those four guys was like the one that I just plotted? Remember, the vertex is at 2, -3. Which one of them looks like the vertex is at 2, -3?
Bottom left.
And we work on the assumption if you don't know the answer, you just pick the bottom left.
Well,
It
I'm
is-
looking at the notes, so it looks the same.
It is the same. So that's the right one. I think I should do a -1 next. I don't have one, so I will do a -1 just to show you. So for the last one of this, and then we'll give you a couple to try yourself, is let's sketch a quadratic with some negatives at the front. So -2x² plus 4x plus 1, right? And I would like to sketch this quadratic, right? So it's just like the one we did over here, right? It's got the same kind of process. What kind of shape have we got this time? Tara wants to rest her voice a little bit. So what kind of shape are you going to get? She's Tara, that's cheating. Aubrey, what were you going to say before Tara was?
I was just gonna say sad face.
Yes. Did Tara's
Or
sad
sad.
face, did that
Yeah.
help or distract you? No comment, okay. So we're now going to do the vertex, which is
After our staunchy Spanish lessons, we can be amusing to each other. That's all I have to say. There's not one moment since that class started that anybody's actually had a laugh. So I have to get my weird up here.
Okay, well, we're going to have a laugh after this one because we're laughing at your face. Now, oh God, if my boss ever hears the things I say about my students, you know I like you, Tara, right? So I'm allowed to be a little bit of backer. So -4 on the top, -4 on the bottom, and we get an x coordinate of 1. Are you happy about the formula allows us to get it? A is -2 and B is +4 here, right? So -b became -4 and 2 lots of -2 gave me -4 on the bottom. They become 1. And then to get the y coordinate, it's this guy plus this guy, add 1. So what's that? -2, add 4, add 1. So I believe that's +3. So we now have a vertex. And it's at 1, 3. So at 1, 3, I do my vertex. And then I remember it's a sad face. Are we comfortable with this process now? So just to kind of tie a little bow at the end of this one, let's give you some questions to try out so you can really make sure that you understand it. I'm essentially going to give you 6 questions, but they're all the same question. Draw a very basic sketch of what these guys would look like. So not surprisingly, I'll just call them 1 to 6. Okay, that's a lot of sketching, but if you use the shortcut, it shouldn't take you that long. Okay, let's give you a. We're
Sorry,
good?
for number 6, did you mean to write plus 12x plus 2?
I did. Thank you. Yeah, I did. Right, you got 6 minutes, 1 minute each, but you shouldn't need 1 minute each. Well, maybe the last 2 you will. 6 minutes, go for it. No pressure. I'll be back in 5. You've got a minute to go. Okay. So we're going to go through these 6. And I need 6 different people to do them. That'll get us all into the game. The first 4 are pretty easy, so we're going to do them pretty much with the answer. And then 5 and 6, I can ask it in 2 parts. Okay, so who's going to go for question 1? I'd pick the easy one if I was you, because you may get landed with a hard one. So I volunteer for the answer to what number 1 would look like, this guy. That's not good.
The
Yes.
the origin's the vertex in that one.
Yeah, and happy or sad face?
Happy.
And you've just, that's you over with. You're done. You're right. Nailed it. Okay, somebody for negative a half x squared. If you tell me it's vertex and happy or sad, that's enough. Number 2, vertex. Oh, okay, it's sad face again. Tara, I got that. Where's its vertex going to be then, Tara?
Sorry, I'm laughing too hard. I don't know. Actually, I didn't even finish that one. I just put sad face.
Okay, when you're right about the sad face then, because someone help her out. When it's just x squared on its own, like it was over here, where does the vertex go?
0, 0.
It's 0, 0. So she helped you out. So when it's 4x squared or a half x squared, anything like that, Tara, if it's only x squared, the vertex is at the origin, right? At 0, 0. Okay. Next one. 2x squared minus 3. Where is the vertex in 2x squared minus 3?
Is it 0, -3?
You're right. It's there.
And it's a happy face.
And that's that one done. Okay, moving on. Where's the vertex in question 4?
Anyone can just answer?
I'm hoping to get a new person each time, but some of you are just too shy or you've went to bed and haven't told me. So I need anybody. Okay, go for it. Anybody then.
0, 4.
Okay, 1, 2, 3. It's about there. Happy or sad face?
Sad face.
And there you go. Can you see the difference between what the equations look like when the vertex is the origin and what the equation, the difference in them when the vertex is a number like -3 or +4?
Mhm.
Now, for the last 2 questions, I was going to do them in 2 parts. Let's get the coordinates of the vertex then. Has anybody got the x and y coordinate of the vertex of this guy? And that's the one that's going to take a bit of time. So you may not have got it finished, but hopefully somebody, at least a couple of you have.
I got 2, -7.
Check in. 2's good. -7 is great. I agree. Happy or sad face?
That one is positive, so concave up.
Okay, so can we pretend that that's at -7? Right, if you choose a scale, you could probably make it -7. Right, would you agree this guy's a sad face? -3x squared, right? Concave down.
Professor, wouldn't graph number 5 be slightly to the right because it's comma -7?
You're right. I'm too busy. You know, the other ones. Oh, at least they're all green. The green ones are right. The black one is wrong. Okay, what's the vertex of this last guy? Anybody again?
214.
I got 2. I'm not saying 14 is wrong, I'm just checking it out. I agree. So can we pretend that that's at 214? Happy or sad face?
Sad face.
Sad.
Sad face. Concave. Right. And that is pretty much the end of that section, right? How to sketch or graph quadratic functions. And we've kind of gone through every possibility that you need to know about. So I thought I would tell you a joke. Do you know that they have just found out that Hitler was Irish?
No way.
Yeah.
How'd they find that out?
Well, they discovered his original birth certificate. And evidently he was born in Ireland. And his real name, his original name, was Richard Potato. But he moved to Germany and he changed his name to Dictator.
I'm very upset that I believed you for about 10 seconds.
Oh, come on, Dictator. Richard Potato, Dictator. Oh, God, that joke died a death. Okay, has anybody, we need a little break, so I'm taking my break right now. Has anybody got another joke for us?
I have one.
Go for it, Kayla.
You're gonna want to kick me out of class after this, but
If I was going to do that, I would have done it to Tara a long time ago, so keep going.
Alrighty then. Why was the bee's hair sticky?
I don't know. Why was the bee's hair sticky?
Because he used a honeycomb.
Ah,
Oh, God. Oh, that was bad.
Am I still?
Yeah, you are still in the class. No, I can't kick people out for bad jokes, or else I wouldn't be here. So, and it kind of grows on me, that joke, right? Anybody got another one? Nadia, do you have a joke?
No, I don't have jokes.
Did you hear that Boris Yeltsin had a prize for the best comedian?
What?
No. And first prize was 1 week in Siberia.
Oh,
And the second prize was permanent.
that's good.
I thought I'd chuck in a Russian joke. Couldn't think of any that bad. Who have we not picked on? Picked on the Germans today. Picked on Russians and bees. Have I not picked on? Did I tell you the joke about the Scotsman and the Englishman in a very fancy restaurant? This is our like 5-minute break kind of thing. In a restaurant, have I told you that one? Right. Well, based on my dictator joke, this one could crash and burn as well, but I'm still going for it. So they'd finished their meal and the waiter had brought the bill, but it was a single bill and it was an absolute fortune. You can imagine what a fancy restaurant would charge for everything. And the Scotsman looked at it and he's kind of, when he saw the size of it, and the Englishman looked at it and went and did the same. And they both just stared at each other because neither of them were going to pay the bill, right? It was going to be a single bill, somebody had to pay it. Nobody was going to budge. And finally, this Scottish voice went and said, I'll pay for that bill. And while I'm at it, I'll pay for everybody else in the restaurant's bill as well. And there's a big headline in the newspaper the next day. And do you know what it went and said? English ventriloquist killed by Scotsman. That's what I got. I got nothing else. Well, we are getting really quite close to finishing. So before we start our next section, I want to show you what we do have left to do, so we kind of get a big picture of what's happening in the next couple of weeks. Because that's all we've got left, a couple of weeks. So here we go. Just setting this thing up. There we go, here. Right, you should be looking, I hope, at our Canvas page. Is that what you're saying, guys? Right, so we are down here. And this one here get moved to this way, and that's fine, there's 5 there. And there's 4 sections left. 10, 1, 2, and 3 are all about exponentials and logs, and that's going to be heavy duty algebra and using your calculator a lot, and that's pretty tough stuff. And one little baby section on a topic called voting, and we're going to look at a very basic version of voting and how you can calculate or how different systems are used to calculate voting. And so what I'm going to be doing today is, for the second part of today, we're going to do 17.1. We're going to do voting, just to get out of the way. And it kind of puts a little break between the graphing stuff and the last section. So once we finish the voting, that'll be us for today. We'll then move on to next day. That'll be Thursday and Monday of the following week, and we'll do these 3 guys. And that means that the Thursday after that, that's a week and 2 days from now, will be a review for the final. That's how close we are to the final, right? 2 weeks to go. So I'm going to be doing this fella on voting. So let me do a whole load of notes on this. I haven't put the homework totally in yet, so I apologize for that, because I really just decided at the last moment to do it this way, but that's fine. So we're going to look at different ways in which typically you can vote. So this is chapter 17.1. And it's called voting. And it's a bit like if you've only seen the one type of voting system, right? If you've only seen voting done in one particular way, that you sometimes don't realize that there are other ways in which people can get elected to typically a political office. But they can do it for any kind of voting. Do you know, if they were doing a vote for the student governor or something, right? You could do different ways, not just majority. But that's the first one we're going to look at. So how does that work? Well, the reason I'm kind of distracted is I've got a blinking window I can't move. Oh God, that was worse. I moved it and it went somewhere else. Simplest system is used by America, for instance, is majority wins. So what can happen here is that, let's say you have 2 parties, we'll call them A and B, and they're doing the governor's election, right? Then simply, don't you just, you have 2 people to choose from, and 514,000 vote for this guy, and 398 vote for that guy, and whoever gets the most votes wins. Now that's called the majority win system, right? It's probably the only system you probably even know about. Right, when you do a presidential election, typically there may be more than one candidate, but realistically, isn't there only two? Right, there are only two people, right, a Republican or a Democrat, that are going to win, and so that would be quite realistic. Of course, if you then go and do like district elections, can you imagine that there were 5 candidates, right, to be elected for a district, right? And the voting went this way: 32,000, 15,000, 18,000, 23,000, and 17,000. Who gets elected for the district in this vote? Here are the number. Say again.
A.
A. Now A gets elected. A got 32,000 votes. We'll just call it 32. That's 50, 60, 70, 83, 113, 115. A gets elected, but only 32 out of 115,000 voted for him. He only got 28% of the vote. Does that seem fair? Agreed. Now, if you're in a country where it's basically a two-party system, it normally that doesn't happen, right? But it could happen, right? And in some cases, what nasty politicians do is that they introduce or they help another candidate enter the race. And that other candidate's job isn't to win. Isn't that other candidate's job to pull votes off your opposition guy? Now, if you're really good at it, can't you sometimes pull enough votes off him to win? So imagine this world. There are 3 candidates. There is A, B, and the guy C came in, and that guy C has got pretty much the same opinions as A. Maybe he says them better, right? Maybe he looks better, maybe he talks better. Right? This guy got 30,000. This guy got 5, and this guy get 31. Who wins the election? Agreed? B does. Is it fair that someone who got 31 out of 66, which is 31 divided by 66, which is what, 47% of the vote, got elected? So the technique that we call majority wins, if there's only 2 real candidates, right, then that works quite well, doesn't it? The guy who wins probably is going to get more than half the votes anyway, right? So it's no big deal. But haven't there been a couple of elections in the last year where there was only a few thousand between the person who won and the person who came second? And that few thousand votes, if there wasn't this third candidate, you know, sucking votes away from them, couldn't he easily have won? So, you know, the majority win system has that disadvantage kind of inbuilt to it. So how do you go about changing that system? Well, one of the classic ways to do this is you have as many candidates as you like, but you have 2 elections. The first election is just to weed out the spoiler votes. And so it you can decide how the rules go, and different places have different rules. One of the most common ones is the first election, everybody can vote for whoever they like, but the bottom 3 candidates get kicked out, and then it becomes a two-way race. Do you see that eliminates the spoiler? Do you know of any type of election which actually uses that system? Because there are ones. Right now, you'll see them. How do you get a Democrat or a Republican nominated for a district? Or for that matter, how do you get only one Democrat and one Republican trying to become the governor? How does that system work? Well, don't the political parties have an internal vote where you vote for your Republican guy, you vote for your Democrat guy, and there's 3 or 4 Republicans and 3 or 4 Democrats, but only Republicans vote for Republicans, right? And Democrats vote for Democrats. And out of that little battle, doesn't there come out one winner?
Yeah, it's the primaries.
The primaries, that's what you call them. But that's basically, isn't that a two-tier system? The first system is to only have one guy to represent your party. Now, theoretically at least, couldn't one of the Democrats or Republicans who never got the job still decide to run anyway? Right? It's a sore loser. I'm still going to run for the governor's election. Won't that guy, let's say he's a Republican, won't that guy take Republican votes off? Right? Political parties, Democrat and Republican, don't like those kind of people. Don't you typically get barred from your party after that? You get kicked out. You don't get financing from the, the main bodies that finance elections. So it's frowned upon. But it is an election system, right? It's called the majority rule. And typically, all you need is half the votes plus 1 if there's only 2 people taking part. So let's show you how the textbook does majority rule questions. Let's suppose there's an election, right? And there's 3 candidates. And in this election, and this does happen in quite a few countries, a lot of this type happens in Europe. You don't vote just for one person. You have a list of people and you pick, let's say there's 3 of them. You pick them in the order that you like them. So you might say, I really like A, that's who I would vote for. But if A doesn't make it, then B is my second choice. And if that person doesn't make it, I have to put C in because there's only 3 guys, right? And let's suppose you had that and 17 people, whatever, 17,000 people voted for it. What would that one represent? A B, an A, and a C. How would that vote work?
You're just giving their priorities, right?
Yeah.
Do
Yeah.
places do this?
Yeah.
What? That sounds like really more accurate. I don't know. You probably get more people who want the same person, right?
Well, what you tend to get in this particular voting system, we're going to do this voting system using majority wins first, but then we'll show you how this same voting system can be tweaked to do a different kind of voting system. There's lots of different ways of doing it. Europe's very, very common to do this system. That's probably why in many European countries, there's like 20 political parties. If you do, it's sometimes called proportional representation. You basically get, if you get 10% of the vote, then 10% of your parliament belongs to your party. Italy's been doing that since the Second World War. which probably explains why Italy doesn't have a stable government. But it's fairer. I'm not knocking that. It's definitely fairer. Right, wouldn't this be my first choice is B, my second choice is A, and my third choice was C? And this one would be my first choice is A, my second was C, and my third was A. And let's say that's 13. So 17 whatever voted for this, 12 voted for that, 13 voted for that. And we are going to try and figure out from this information who won the election if you do majority votes, right? So we're still on majority votes here. So would you agree in this one here, A gets 17 votes. In this situation here, since it's only the first person that matters, the first choice, B gets 12 votes. And won't this one, well, this one here also is B. And in this third situation, B gets 13 votes. Now, if I add these together, I get 30, I get 42 votes. A, 17 in total. B, 25 in total. And C didn't get anybody who picked him their first choice. Can you see here that B wins? Do you see how that system works? Basically, your first vote is your only vote. The other two in these situations don't really get counted, right? Now, what some places do, and there's tons of versions of this, can you imagine there's a dead heat? You know, 20 people, 20 people. How do they decide then which one of them it is? Well, you could just do the election again, but that's a lot of time and trouble. What they then do is they look at the second choice. And whoever gets more second choices than the other person wins. So that's a variation on that. Here's a different way of doing this voting system. We're going to keep the same numbers, and we may get the same result, and we may not. In this system, you award points to the position. And the points go something like this. You can choose whatever points you like, but typically you would do them consecutive numbers. So how about this? You get 3 points if you were picked first, 2 points for being chosen second, and 1 point for being chosen third. Right? So I'm putting in the same data up here. 17 people voted with that combination. 25 people voted with this combination, and 13 people, right, voted with this combination. Now this gets much more complicated.
The middle's 12.
Oh, you're right. 12. Now in this voting system, things get a little bit more complicated. There's 3 points, 2 points, and 1 point. There's 3 points, 2 points, and 1 point. First, the total number of points has to be calculated. It's kind of helpful to know that. 3, 2, and 1 give you 6. So that's 17 times 6, 12 times 6, and 13 times 6. So in this case, I have 17 times 6. There's 102 points. 12 times 6. There's 72 points. And 13 times 6. There is 78 points. And that's 10, that's 2, carry 1, 15. There are 242 points. So whoever gets more than half points wins the election. Right, so half these points, right, wins the election. Now, if that doesn't happen, then the biggest wins. Okay, so let's see how many points candidate E gets. 17 people voted for that person first. So here we'll get 17 times 3. 12 people voted him second in this group. 12 people voted him second. And in this last group, 13 people voted for him last. And so that's 51, 24, and 13. And that's 70, 80. I make that 88 points. Do you think candidate A is going to win this election? Do you think 88 points is a big enough total? Okay. So let's look at candidate B then. In candidate B then, 17 people voted for them to be second. So that got 34 points. 12 people voted for them to be first, which is 36 points. And 13 people voted for them to be. Did I get that right? This is B. Yeah. And over here, 13, 3 again, 3 points. So it's another 39. That's 19, 109 points. Is that more than half? Nope. But you might still be the winner. I guess for completeness sake, I'll do C. But I'm pretty sure I know C is not going to win, right? But we should do it. 17 at 1 point. 12 people gave them 1 point. And 13 people gave them 2 points. 17, 12, and 26. And that's 8 and 5, 7, 15, 3, 4, 5, 55 points. So in this particular system, where you award points to first, second, and third, B wins. And he wins, or she wins, because they have got more points than any of the other candidates. Right, now I'm going to show you another one of these, right? But this time, I'm going to try and make a different result happen. So we're going to have, these are the only combinations I'm picking, but there's obviously there's plenty more. And we're going to have 10, 10, 10. So in this election, 10 people voted for A and then other people, 10 voted for B, and 10 voted for C. Do you see that's a tie, isn't it? If you were doing majority vote, 10, 10, and 10, right? It's a three-way split. Now, we're doing the 3, 2, 1, 3, 2, 1, 3, 2, 1. In this case, 60, 60, and 60. So that's 180 points are up for grabs. So I'm going to find out candidate A, candidate B, and candidate C. Candidate A, right? In this set here, 10 people said they liked him, so he gets 30 points from that group. Over here, 10 people didn't like him so much, he only gets 10 points. And over here, 10 people didn't like him so much, he gets 10 points. This guy gets 50 points. Do you think B or C is going to win? Or maybe you think he's going to win. Who do you think is going to win this election? No idea, Tara. Okay, let's
I think
do
it's
B.
B.
Then. Okay. In this group here, 10 people picked V in the middle, so he gets 2 points for that happen. In this set, 10 people liked him, so he got first place. And this set, 10 people, second place. So what's that going to be? 20, 30, and 20. And that gets me 70 points. So he's definitely going to beat candidate B, right? And just for completeness sake, I'm going to pick C. And 10 lots of 1 point, 10 lots of 2 point, and finally 10 lots of 3 points. And that gets me 10, 20, and 30. And that's 60 points. So can you see this weighted system can be used when there's multiple candidates and you don't want to just do majority wins? It is possible for you to have a combination where the person who got the majority wins person isn't the person who wins when you use this system. Can you imagine that you have a lot of people who like you, so they pick you first, but everybody else hates you, so they always pick you last? Can you see a person who might not get as many first votes, but gets a lot of second votes, could add up to a bigger total than you could, and therefore can win the election? This system is also used when you want to have two people getting picked, right? Suppose you were doing votes for the school board, right? Couldn't you have a system based on points, where they were in the list? And you want 3 members of the school board. So the people with the 3 highest points get elected. Otherwise, you'll be having votes, you know, oh, let's just vote for first. Okay, we got that person. Let's re-vote now to see who the second person is going to be. Oh God, let's vote another time for that. Can you imagine how messy that would be? Couldn't you just have one vote where you put preference? I like this person, him second, or third, him fourth. And that would be a system where you would just give a point scheme to it. Do you like that system? Every system has pluses and minuses. I mean, isn't what's sometimes called first past the post, right? You know, majority wins. Isn't that a simple system, right? This guy got more votes than this other guy, he wins. Can you imagine having a very complicated point system? Wouldn't people be suspicious of the winner if somebody came out and said, well, I got more people voted for me first, but this other idiot, he got the job? And that could harm, couldn't it? And it can cause all sorts of false impressions that there's something nefarious going on. And that's because most people don't understand that system. Would you agree it's kind of messy? And if you were trying to think, why did he not win? Your first suspicion is, oh, foul play. But can it just be he didn't get enough people who liked him in second place as well, right? What does this system tend to reduce? It tends to reduce extreme candidates from being elected, right? Extreme anything, right? Extreme Republican, extreme Democrat, right? Whatever it is. Because if you're an extreme person, won't you get a lot of people who like you, but not enough? Everybody else will hate you and make you the last choice. He's the last person I'll ever pick. And so when you do the point system, you tend to not be first because of that. Whereas wouldn't a middle of the road candidate get a lot more second and third places? And so they could end up with more points. You can also weight this any way you like. 3-2-1 is only one weighting system. Couldn't I decide that it was 5, 3, and 1 point? Right, 5 points if you're picked first, 3 points if we pick you second, and 1 point if we pick you last. And it'd be interesting to know who's in charge of the point system. Right, who decides? Is it 3-2-1 or 5-3-1? Or maybe 5-3-0, you don't get any points if you're last. Right? So it is open to manipulation, this new system, but it is versions of it, at least, are quite common. If you want to know what this method is called, so you can go look it up, it's called the border count. I'm assuming it's after a guy called Border. Right. Okay.
I have a question that's on the homework.
Sure.
Most of it's pretty straightforward, like what you're talking about.
Yeah.
But this one says, how many different ways can a voter rank 3 candidates? No
Oh,
time.
okay.
Ah,
Let's do that.
that's
Yeah,
easy.
by the way, that homework's not finished yet because I only got halfway through, so you won't find any border questions yet, but they will exist, right? But let's go back to your question. 3 candidates, and it was how many ways can that happen, right? Right. This is a counting method that you use. 3 candidates. 3 numbers are going to be multiplied together to find the total number of ways this could happen. When you come to the first candidate, isn't there 3 choices? Could be A, could be B, could be C, right? 3 choices. Now, once you've chosen him, isn't there only 2 people you can pick for the second one, right? Because the first one's used up. And once that's done, isn't there only 1 person left for the end? So that ends up being 6. So there's only 6 of them, right? For 3 candidates, there's only 6 combinations that are out there. And let's tell you who they are then. ABC, ACB, BAC, BCA, CAB, and CAB. Right? Do you see all 6 combinations there? Let's suppose we had one of the Italian elections and there was 5 candidates, A, B, C, D, and E. How many different combinations, right? Different ways could you pick from those 5, right? Now, 1, 2, 3, 4, 5. Okay, how many for the first one?
5.
Agreed. Once you've chosen, how many ways for the next one?
4.
Then 3, then 2, then 1. And that gets you 20,
100.
60. Yeah, there are 120. I am not going to write them all down, right? But there are 120 combinations. Now, can you imagine what the voting paper, do you know the kind of one that you would get would have, you know, John Smith, Republican, somebody else Democrat, and who knows, independent, right? You'd get a thing like that, and all you do is like you cross whoever you want, right? When these get counted by hand, right? If you did them by hand, isn't it relatively easy to do it? Don't you just have 3 buckets? Well, maybe a 4th one down here. Republican, Democrat, and Independent. And so the person just said, oh, okay, Republican, Democrat, Democrat, Independent, Republican, right? And they do it. It's pretty quick, right? And it's not that difficult to screw up, right? It'd be hard for you to, occasionally you stick a Democrat in a Republican box or vice versa, right? But won't that get that'll get caught up in the recount, right? When they go through them at the end and they count all the Republican votes. And that's a paper vote. And as long as the votes are protected from the polling station to the counting station, sometimes it's the same building, which is good, but sometimes they move them. As long as that's kept secure, you can be pretty comfortable that the votes are correct. Can you imagine in Italy where there's 5 candidates and there's 120 combinations? How do you even set about figuring out the point system, right? So let's say you go 5, 4, 3, 2, 1, right? You got 100,000 votes for Rome. 5, 4, 3, 2, 1. Can you imagine the mistakes that can happen in such a counting system? I mean, do you have 120 buckets for each combination and you stick the vote that matches that exact combination? Well, that would be horrendous to administer, wouldn't it? Oh, I've got this guy. Now I have to find out which one of the 120 buckets to put it into. It's basically their boxes, right? So what do? They take each one, I guess, and they process it one at a time. And you type it into a computer and you let the computer do it. Well, what's the problem with letting a computer do it? The computer's fine. What happens if the person types it in wrong? Right. You see that, yeah, how do you even check it? It's a very difficult system to check. That's a drawback from it. If there's lots of candidates, if there are only 3 candidates, it's not a big deal. But if there was 5 candidates, it is. And why do you have another bucket? Don't you always get a vote where some idiot crosses 2 of them? Right? Oh God, I didn't mean the Republican, I meant the Democrat, so I'm going to rub that out. What happens to votes when you do that? What
I
happens to
suppose they
somebody's?
get discarded.
They do, they get discarded. So don't screw up your vote by doing that. They typically are discarded because, and then people start arguing and say, well, it's pretty obvious what the person meant, right? They wanted a Democrat and they changed their mind. But then you could say, well, yeah, but what's to stop other people from crossing out Republicans and putting Democrats in the later votes as well? So it's a protective device, you know. Because if I was unscrupulous, couldn't I take all the votes and just put in lots of extra X's and little crossy outs to get more of my guy in? So if you just kill those votes, doesn't that stop people from cheating in that way? So, I mean, you got to lose some votes, I guess, but, you know, the alternative is quite bad. I don't think you want to be a counter in that place, do you? I don't think anybody would want to do that job. There is a true story, allegedly. Australia does a version of this system for a lot of their elections. In Australia, you have to vote, right? It's a law. You know, in America, you can choose to vote or not. And so what they do in Australia is that if you don't vote, you get a fine. So, I mean, I guess you can choose not to vote, but then you have to pay them money, right? Because that's what the fine is, right? You give them money. And for people who just don't like voting because maybe religious beliefs or whatever beliefs, they pay the fine, I guess. But what they had noticed is, I think it's, don't quote me, but I think it's called the donkey vote. So what's the donkey vote? You get a piece of paper with maybe 9 candidates on it. And you're meant to order them from who you like first to second to third, you know, all the way down to whatever number you stop at. And do you know what the donkey vote is? 1, 2, 3, 4, 5, 6, 7, 8, 9. You have voted, you do not get a fine. It's a, you know, a mail-in ballot, right? Or as a turn-up ballot. And so if you wanted to get elected or get a little edge on the opposition, shouldn't you change your name to Aaron Aardvark? And you'll get the donkey vote. And I don't know what the percentage is, so I'm lying here, but about 5% of Australian votes in some areas are donkey votes. And couldn't 5% win you an election? You could actually get voted in, not by the 5%, but the fact you get an extra 5% that you wouldn't have got otherwise, right? So we'd assume you'd still be a major candidate, but you get the donkey vote. I think that's a good place for me to kind of stop. So there are two main ones. There are not two main. There are tons and tons of different ones, but we could spend forever in a day. But the two main ones are going to be the border count, right, where you give scores to people, or the majority rules one, right? And that's the only two that you're going to get homework questions on. Right now, there's only questions on the majority rule because I haven't got to the border count questions because, you know, I get cut off with time. Right, any questions before we call this a day? This is a good point for us to finish. Do you want to go to Italy and vote?
I want to go to Italy.
I don't blame you. Italy is good. I don't know how they do it. I honestly don't know how countries who use this system actually can keep an eye on it. It seems to me dangerous, I guess, maybe. But it can be, and it very often is considered to be fairer. So, anyway, bye-bye. Say hi and bye-bye, everybody.
Professor, I have a question, please.
Go for it, Nadia. What you got?
Well, I have a little problem with my calculator.
Okay. What's up?
So, as a matter of that, I was calculating one of the questions from homework, and I pressed for function statistics, and then I tried to delete. I pressed delete many times, and I deleted all. Can you see it? There is.
Oh, okay.
Yeah,
Right.
usually it was showing like L1, L2, L3, and now it's counting weird. Like with
I will show you how that has happened to students before. You're not the only one to do that. So I'm going to show you how to fix your calculator to get back your stuff, right? So if you, I'm putting on my big calculator on the screen here, and you can maybe follow this through. Are you looking at a TI? Pardon me. Are you looking at the TI-84 calculator, the silver edition here?
yeah, I can see a calculator.
Okay, so I'll make sure it's on. What you're going to do is, do you see the plus button? There's an MEM above it in blue. So you're going to go blue button plus.
Sorry, I need to, like, just a second.
Yeah. When you're ready, blue button plus sign.
Okay, you said what?
Blue button, that second button, whatever, yours might be yellow, but whatever that button, second, and plus.
Just regular plus, right?
Yep. And you should be looking at the screen that I'm looking at. Is that what you see?
Yeah, it says memory and
Lots of stuff, just like my screen. That's good. Now, I want you to go down to choice number 7, reset.
just a second. I need to write down. So you said number 7, reset.
Correct.
And then enter, right?
Yes. Now, what we're going to do here is we're going to clear out everything in your calculator. So it takes a few, you have to kind of do more than one thing. And this 9 times out of 10 fixes it. And if it does, then that's great. And if it doesn't, there is 2 more fixes that I can do, but I don't want to do them unless I absolutely need to. So,
So
okay.
what can I press now?
Well, do you see the one at the top that says all RAM?
Yeah,
You're going to put enter.
this one.
Yeah. And then it's going to say 1 no and 2 reset. Do you see that? 1 no and 2 reset, because we're going to reset the RAM. And you're going to choose option 2, which is reset the RAM. That's basically reset all the memory.
To reset.
Right, and hit enter.
Enter.
Okay, right. Now, second, plus again. Go down to number 7 again. We're going to repeat it. Choose reset again.
Just a second. second plus
plus number 7 reset,
second plus again. Okay.
and right,
Um,
and now we're going to choose the
Just-
second choice.
Just give me a second. So I'm seeing memory and then what?
Right, number 7 reset.
Number 7.
Yeah, we're just basically going through the same steps that we did at the beginning. We're going to just change the little bit at the end. So you should be seeing it right now. Right, you seen that memory? Number 1 all RAM and number 2 default again.
So I press number 7 and it says all RAM. And what do I need to do?
Now you want to go to number 2 defaults.
Just a second. I'm writing down
Sure.
and enter, right?
Yeah. And it's going to give you a choice again. And you choose number 2 reset.
Okay.
Okay. Number 2 reset and hit enter. Or if you hit number 2, it does it automatically.
It says that
Yeah,
one.
that's exactly what mine says. Right now, you go back in and see if your L1s and L2s are back. Should be fixed now.
I'm sorry, can you repeat it one more time?
You lost all your columns. Remember the problem you had? They'd all disappeared.
Yeah.
Go back in and they should be there now. Check that they are.
Yeah, it's showing L1, L2,
So
L4,
everything is fixed. It's back to where it was.
5, 6. Yeah.
Okay.
That's it. Thank you very much.
You are welcome. Okay. Anybody else got a question?
I do.
What you got for me?
So for me, it's just, I don't know if like, I just made a mistake, but
Uh-huh.
on one of the homeworks, like
Yeah.
14.3,
Yeah.
it kept saying that my median was wrong.
Ooh. Number
Um,
14, is it 14.3?
14.3, yes. Number
Okay.
2.
Okay, 14.3. Clicking on it, I'm just finding out what the question is. Number 2.
Yeah. I put 2.5, which is like, because it's 0, 1, 2, 3, 4, 5 or more.
Yeah, but what you didn't take into account is the percentages that are there.
Am I supposed to put in order? Like,
Well, what we've got here is, right, let me show you what I'm looking at, and then we'll show you what the median looks like. These are not the normal questions. See, the typical question that you get, you just have 5, 6, 7, 9, 9, 9, and you pick the one in the middle, that kind of thing. And so what you were doing, that was perfectly sensible. But when you have a table like this, right, are you looking at a table similar to the question 2 that you had to do?
yes, sir.
Right, let's make it a little bit bigger then. When you have a table like this, where it's percentages, right?
Mm-hmm.
What you need to do here is realize that the middle number is at the 50% mark. And can you see at the 50% mark, one of these number 2s is there. So it's not like you've got a single 0, 1, 2, 3, 4. It's like you've got 50 zeros and 29 ones and 302 2s and things like that. And so you have to use that information as part of the process to get the middle. So when you've got tables like this, right? When you've got tables, cumulative percentages, and that type of thing, right? As we have here, what you want to do is find out which number has the 50% in it, right? See, this guy has 42, and this one finishes at 73. So this group here has the 50% mark in it. And so that's why the answer is just 2.
Oh, so it's just a solid number?
Yeah, so it's one of the